Finding limits graphically and numerically, Part 2. Welcome back, guys. In this video, you will learn the formal definition of a limit and how to prove the limit of a function using the formal definition of a limit. Proving the limit of a function using formal definition of a limit will be on your first exam. So make sure to learn how to do this, okay? Before we start, we need a quick review for the absolute value inequality. Here we go. So absolute value less than 5. What does that mean? It is asking what are the values of x if we want the distance of x from 0 to be less than 5 units on the number line. So if I graph this, such numbers whose distance from 0 less than 5 will be any number who lives within negative 5 to 5. So all these numbers, not including negative 5 and 5, because we want distance to be strictly less than 5. All those number that is shaded inside of a parenthesis will be the solution for this absolute value inequality. If I rewrite the solution, x should be between negative 5 and 5. Or you could also read it as x is greater than negative 5 and less than 5 at the same time. All right, so then what does the absolute value of x minus 2 less than 5 mean this time? This time, absolute value of x minus 2 less than 5 means what are all values for x if we want the distance of x from 2 is less than 5 units this time. So center is not 0 anymore on the number line. We want center to be 2. So center is 2, and we want the distance to be less than 5 again. So this point will be 2 minus 5, and this point will be 2 plus 5, since this is a 5 units, and this is also 5 units. So typically this is the center, and this is the distance we want within. Okay? So how would we write an absolute value expression such that x is greater than c minus delta and less than c plus delta? So obviously center here is c, and distance from c to left and right are delta units. So if we write this in absolute value inequality notation, this would have been variable is x. So we want all x from center C that distance is less than delta units. Then x would be all numbers who lives in C minus delta to C plus delta. Can you do it if we have variable as f of x and center is L? Sure, same thing, right? So here we go. We want all the values of f of x from center L, whose distance, what is distance from L to L plus epsilon? Epsilon. What is the distance from L to L minus epsilon? Epsilon. So we want all f of x from center L whose distance is less than epsilon. Very good. You are now ready for the formal definition of limit. Are you guys ready? Here is formal definition of limit. Let f be a function defined on an open interval containing c, and let L be a real number. Then, limit x approaches c of f of x equal L means the following. For any given epsilon positive number, if there exists a positive number delta such that whenever distance of x and c is less than delta, then distance of f of x and L to be less than epsilon. Okay? They're saying, hey, for any epsilon given, I could say epsilon is 0.01, I could say epsilon is 0.005, then this will be L minus epsilon, and this will be L plus epsilon. Now, can you go back where the C is as x approaches to C? Can you find the distance delta so that this is C minus delta and this point is C plus delta, so that whenever your choice of x is in that interval, its function value would be inside of the interval L minus epsilon to L plus epsilon. If you could do that for every epsilon, limit as x approaches c of f of x equal L. That's what this definition is saying. Okay, if we see an example, it will make more sense. So let's do an example. It says find the delta such that the distance of f of x and the limit L would be less than 0.01. Whenever your choice of x and the center C, the distance of that is less than delta. And given limit x approaches 5 of function 2x minus 3 equal 7. So here, x is approaching to 5, so C is 5. My function f of x is right here, 2x minus 3, and my limit is 7. And they're saying, hey, my epsilon here is 0.01. So this is limit, which is a 7, and my epsilon is 0.01. This is 0.01. This is 0.01. That means I want function value to be in the interval 7 minus 0.01, which is 6.99, to 7 plus 0.01, which is 7.01. Now, so can you go back to X neighborhood? So give me distance, the delta from the center x equal 5, so that if I choose any x from 5 minus delta to 5 plus delta, then its corresponding function value would fall in the interval 6.99 to 7.01. Okay, so let's try if we can do that. So you start with this conclusion part and we go backwards and try to get this. So right now we want absolute value of f of x. Our f of x is 2x minus 3 minus L. Our limit is 7. We want this to be less than 0.01. That's our goal. And we have to find the right delta that would do that. So now from here, it's easy. You just do the algebra. Go ahead and rewrite this expression without parentheses and simplify. 2x minus 3 minus 7 is minus 10. We want that to be less than 0.01. Now we can factor 2 out from 2x minus 10. So that will be 2 times x minus 5. We want that to be less than 0.01. But from algebra fact, absolute value of AB is equal to absolute value of A times absolute value of B. So we can separate this absolute value, but absolute value of 2 is 2. So we have now 2 times the absolute value of x minus 5 is less than 0.01. So then we divide both sides by 2 And we get absolute value of x minus 5 has to be less than 0.005. Now what? Remember, we are trying to find delta from this absolute value of x minus c less than delta, because what's given to us is limit as x approaches 5 to f of x equals 7. Our c is 5. So then we have absolute value of x minus 5 less than delta. We want to find right delta so that we can have this result. But to have this result, we found out that absolute value of x minus 5 has to be less than 0.005. So therefore, we found our delta. Our delta has to be 0.005, because if delta is 0.005, absolute value of x minus 5 will be less than 0.005, and therefore our absolute value of f of x minus 7 will be less than 0.01. Do you want to check? So for example, if delta was 0.005, this point will be 5 minus 0.005, which is 4.995. And this point right here is 5 plus 0.005, which would be 5.005. So choose any x in that interval. Let's say my x is 4.999. So then what would be my f of x? I gotta make sure then f of x value has to be in the interval 6.99 to 7.01. And f of 4.999 would be equal to 2 times 4.999 minus 3, which is equal to 6.998. Is 6.998 inside of interval 6.99 to 7.01? Sure it does. You can actually pick any value you want from 4.995 to 5.005. That f of x would be inside of 6.99 to 7.01. Therefore, we know the limit as x approaches 5 of 2x minus 3 equals 7 by the formal definition of limit. So now we're actually going to learn how to prove limit of a function using formal definition of limit. We also call this epsilon delta proof or delta epsilon proof or proof by formal definition of limit. So let's see one. Prove that limit as x approaches 2 of 4x minus 3 equal 5. So here is proof. You have to start by given epsilon greater than 0 because that is the part of definition. You're gonna say choose delta equal and you're gonna leave them blank because you will not know at the point. As you are almost done with the proof, you will know what the delta has to be, like last example. Then for distance of x from 2 less than delta, we will get, and then you're gonna write absolute value of f of x minus L. Remember, our f of x here is 4x minus 3. Our c is 2. Our L is 5. So this has to be f of x minus L. So you write absolute value of 4x minus 3 minus L, 5, equal, and then you will simplify what's inside of absolute value. So you will get 4x minus 8 and use the property of absolute value. If you factor 4 out, it is absolute value of 4 times absolute value of x minus 2. But as you know, absolute value of 4 is 4. So this becomes 4 times absolute value of x minus 2. And we want absolute value of x minus 2 to be less than delta. So that expression has to be less than 4 times delta, but we want it to be end with less than epsilon. So in order for you to get this equal epsilon, you can divide both sides by 4 so that we know that delta must be equal to epsilon divided by 4 so that we can have that flow. So then you go back at the beginning of this proof and plug what the delta has to be, like you knew from the beginning. This way you save a whole step doing it all over again. So you now write what the delta has to be, and then we say, so therefore, at this step, 4 cancel, and that would give me less than epsilon. So you show, given any epsilon positive, if your delta is whatever epsilon divided by 4, then difference of fx from L has to be less than epsilon. So therefore, we conclude limit x approaches to of 4x minus 3 equal 5 by formal definition of limit. Okay, let's practice how to prove limit using formal definition of limit. Prove the limit using a delta epsilon proof. Can you prove a limit as x approaches 6 of a function 3 over 2x minus 2 equals 7? How do we start? You have to start by, I said, given epsilon positive number, we're gonna say choose delta to be equal to, we don't know yet what the delta has to be, so leave them blank. Then whenever distance of x, and what's my c? My c is 6. So x and c, 6, is less than delta, we get absolute value of f of x. And what is my f of x? It is 3 half x minus 2 minus L, and my L is 7 here, 7, and then you clean it up inside of absolute value. So that's a 3 half x minus 9, which is equal to, I would like to factor out 3 half and write x minus, and what should go inside of absolute value so that 3 half times this number is 9? You can do inverse operation, right? You can just do 9 divided by 3 over 2. You will know what should go inside, which is 9 times reciprocal, 2/3, then 3 times 2, which is 6. So that will give me absolute value of x minus 6. Look at this. That's what I need here, right? I needed to find out absolute value of x minus 6 has to be less than one number, and it's right there. So we know this is equal to absolute value of 3 over 2 is 3 over 2, absolute value of x minus 6, and I know this is less than 3 over 2 delta, because absolute value of x minus 6 will be less than delta. That's our hypothesis. And we want this to be end up with epsilon. So to get epsilon, we solve this. To get rid of 3 over 2, we can multiply both sides by reciprocal of 3 over 2, which is 2/3. So then 2, 2, 3, 3 cancel. You know your delta must be equal to 2/3 epsilon. So you can go back now to the original statement and say choose delta to be equal to 2/3 of epsilon. And then you can erase it here so that your proof flow naturally. That will give me 3 over 2. This would be less than 3 over 2 delta. And then replace what the delta is equal to. And that would give me less than 3 over 2. What's my delta equal to? 2/3 epsilon. So then 2, 2, 3, 3 cancel. That will give me less than epsilon. So therefore, what's the conclusion from this proof? The limit x approaches 6 of my function 3/2 x minus 2 is indeed equal to 7. And you're done with the proof. Not too hard now, huh? Let's do another one. Prove the limit using a delta epsilon proof. Limit x approaches 4 of function 3 minus half x is equal to 1. Let's determine what's my c and fx and l are first. So here's my c. My c is 4. My function is this, 3 minus half x. And my limit L is 1. Proof. How do we start? Yes. Given epsilon positive number, we're going to choose delta equal what? We don't know that yet. We're going to leave them blank there. Then for any choice of your x from center C, which is 4, is less than delta, we get absolute value of f of x. My f of x is 3 minus half x minus L. L is 1, which is equal to, we want this to be less than epsilon. Okay, so then 3 subtract 1 is 2. So I have a 2 subtract half x when I simplify, which is equal to, well, we would like to get absolute value of x minus 4 less than one number. And we have to get it from this. That doesn't look anything like what I need. So we don't want negative x, we want positive x minus number, right? So you would like to factor the number in front of x, which is negative 1/2. So let's take it out, negative 1/2 times absolute value of x, and then what number goes there? You can do opposite operation, right? What was in there is 2. So instead you do 2 divided by what you took it out, negative 1/2, which will be 2 times reciprocal of negative 1/2 is negative 2. So the number that would go in there will be negative 4. And that's exactly what you needed, right? It always fall like that. If you don't get that, then you are doing something wrong. So here we go. And absolute value of negative 1/2 is 1/2 times absolute value of x minus 4. And by hypothesis, absolute value of x minus 4 is less than delta. So we can substitute absolute value of x minus 4 by delta. And we want this to be end up with epsilon. And to get that, you can multiply both sides by 2. Then you know the delta has to be 2 times the epsilon. So you found your delta. Your delta has to be 2 times the epsilon. So you can go back to the original problem and say, hey, choose delta equal whatever epsilon is, do twice the epsilon. Then, whenever you choose x in the delta neighborhood, the distance of your f of x and the limit would be less than epsilon. So anyway, and then you erase this part. This is less than 1/2 times. What is your delta? You can replace by 2 times epsilon. And then 2 cancel, so that will give me less than epsilon. So therefore, you can conclude that limit x approaches 4 of your function, 3 minus half x is equal to 1. Easy. Guys, let's do one more since we are on fire. Prove the limit using a delta epsilon proof. limit x approaches -1 of 6x plus 9 equal 3. So what is my c? -1. What's my f of x? 6x plus 9. What's your L? 3. Okay, so here's my proof. How do we start? Given epsilon greater than 0, choose delta to be equal to, we don't know. We'll find out. Then, for absolute value of x minus c, my c is -1. So x minus minus 1 will give me x plus 1 less than delta. We get absolute value of f of x. F of x is 6x plus 9 minus L. L is 3, which is equal to absolute value of 6x plus 9 minus 3 is plus 6. Then we can factor out 6 and have an absolute value of 6 times absolute value of x plus 1. Look at that. That's what I exactly needed. This will be less than 6 times absolute value of x plus 1 was less than delta. And we want this to be end up with epsilon. And for delta to end up with epsilon, we can multiply both sides by 1 over 6. And we know our delta then should be equal to epsilon divided by 6. So go back to the beginning of a proof. Choose delta to be epsilon divided by 6. And then I can erase right here since this is my middle of proof. And now this would be less than 6 times delta is equal to epsilon over 6, and 6 cancel, so this will give me less than epsilon. Woohoo! Therefore, limit x approaches -1 of my function 6x plus 9 must be equal to 3. Done. In next example, your function is gonna be quadratic and it's a little bit harder, but it's a very similar idea. We are ready to learn how to prove limit of a quadratic function now. Prove the limit using a delta epsilon proof. Limit x approaches 5 of quantity x squared minus 3x equal 10. So again, my c is 5. F of x is quantity x squared minus 3x. L is 10. And here is proof. Given epsilon greater than 0, choose, and here is difference for quadratic one and the linear one. Choose delta to be equal to, and every time you have a quadratic function, you have to write delta to be equal to minimum of 1 and what to be found. And this is a function too. Minimum of 1 and something is asking you to choose whatever the smaller is. Because we want smaller delta. I'll also explain to you why we want smaller delta versus larger delta. Then for x minus c, my c is 5, less than delta, we get absolute value of f of x. My f of x is quantity x squared minus 3x minus L. L is 10, which is equal to, when you write this without parentheses, it is just quadratic expression of x squared minus 3x minus 10, which factors. And this guy factors as x plus 2, x minus 5. And because they're product, you can split the product using absolute value as we learned. So now I know I would like to find out absolute value of x minus 5 has to be less than what number. So this we would like to keep. But before, what was in front of that was a number. However, this time I do have a absolute value of x plus 2 instead of number. So we want to replace that expression by a number. So what you're going to do is you're going to draw a number line. What is x approaching to right now? X is approaching to 5. So write a neighborhood of a 5. So before 5, what's another integer in front of a 5? That will be 4. And what about number to the right? That will be 6. So for now, we're letting delta to be as big as 1. That's why we said let delta be minimum of 1 and a number. And when x approaches to 5, remember, we want like x to be 4.99 or 4.999. We don't want delta to be this big, but just to be safe, we're letting delta to be equal 1. Why? Because we want to know how big this absolute value could be. If delta was greater than 1, then x is not approaching to 5 no more, right? So you know it cannot be bigger than 1. So then this expression x plus 2 could be, when you plug 4 in there, 4 plus 2 absolute value. So that expression that I want to get rid of could be as small as 6. Or absolute value of x plus 2 could be, when x is as big as 6, 6 plus 2, which is 8. So this expression here, x plus 2 absolute value, has to be a value between 6 and 8. But remember, next step is to call this either less than 6 times delta or 8 times delta, and we're gonna set that equal to epsilon to see what the delta has to be. But we want smaller delta of the two. So your delta could be either epsilon divided by 6 or epsilon divided by 8. Which one is smaller? Epsilon divided by 8 is smaller, right? And we want smaller delta. And I will show you right now why. So look at this graph right here. So let's just say one of my delta is zero point 0.1 and another delta is 0.3. If I have a choice like this, and if you choose delta to be bigger one, let's say zero point 0.3, then guess what now? You might choose x, that when you find f of x, it might not be within the epsilon that you wanted. You want to choose always a smaller one. For here, you want a 0.1, because then every x you choose from delta minus 0.1 to delta plus 0.1, its f of x going to be for sure inside of interval from L minus epsilon to L plus epsilon. Do you see? So if you have a choice, we always want to choose a smaller delta. Now back to absolute value of x plus 2 expression. We found that that expression lies between 6 and 8. So our problem is, are we going to replace that absolute value of x plus 2 by 6 or 8, knowing we want the smaller delta? We know at the end we have to divide by the number to determine what the delta has to be. So if we replace by 6, our delta is going to become epsilon divided by 6. If we replace that absolute value by 8, delta is going to become epsilon divided by 8. Which number is smaller? Epsilon divided by 6 or epsilon divided by 8? That's right. Epsilon divided by 8 is smaller. So we don't want to replace by 6 there. We want to replace that by 8. So then we want to divide both sides by 8 to determine what the delta has to be. So we found out, and our delta has to be minimum of 1 or epsilon divided by 8. And then I'm going to erase that part and continue. This is less than 8 times. Now, What's my delta? Delta is minimum of 1 or epsilon over 8. If minimum of 1 or epsilon over 8 is 1, that means it's smaller than 8 times than epsilon over 8. Since the minimum of 1 and epsilon over 8 is 1, meaning epsilon over 8 is bigger. So then this is less than 8 times epsilon over 8 anyway, and 8 cancel, and we get less than epsilon. Or if minimum is epsilon over 8, then we could replace this step right here by epsilon over 8 so that this become less than epsilon anyway. Either way it works. So on the test, you don't have to do the one part because typically, like I said, delta cannot be that huge, like 1. It's going to be very teeny tiny numbers since it's going to be epsilon divided by 8. And to prove the limit, epsilon is going to be already a very small number. So small number divided by 8 is going to be a very small number compared to 1. 1 is a humongous number when you're talking about the limit. So more likely, your minimum is going to be epsilon over 8 anyway. So you can just choose epsilon over 8 since if it minimum was 1 like I show you, it will be still less than epsilon over 8 anyway. So then you can conclude, therefore, limit x approaches 5 of function x squared minus 3x is equal to 10. Last one, guys. Prove the limit using a delta epsilon proof. Limit x approaches -2, quantity x squared minus 2x minus 3 equal 5. So here's a proof. Given epsilon greater than 0, choose, this is quadratic one. So what do? Choose delta to be equal to minimum of 1 and the value to be found. Then for absolute value of x minus c, and my c is -2. So x minus 2 is absolute value of x plus 2 less than delta. We get absolute value of f of x. Our f of x is x squared minus 2x minus 3 minus L. My L is 5, which is equal to, simplify what's inside of absolute value, we get x squared minus 2x, -3 minus 5 is minus 8, which is equal to, you can factor that, and when you factor it, you get x minus 4 times x plus 2. And what I want to know is absolute value of x plus 2 less than one number. So this is what I would like to keep. And absolute value of x minus 4 is what I would like to get rid of. So we are going to draw a number line here. And x is approaching to c. And my c is -2. And we're going to temporarily let delta to be equal 1. So what's the integer left side of -2? That's a -3. What is the integer right to the -2? That's a -1. Then the value you want to get rid of, the absolute value of x minus 4, if you replace -3 there, I get -3 minus 4, which is equal to absolute value of -7, which is 7. And then what about absolute value of x minus 4 when x was -1? Then this give me -1 minus 4, which is absolute value of -5, is equal to 5. So you know absolute value of x minus 4 is actually from 5 to 7. And we want to choose a larger number to get smaller delta. Is that right? So we're going to replace this. We know absolute value of x minus 4 has to be less than 7 times absolute value of x plus 2. And by hypothesis, this has to be less than 7 times delta. And we set this to be equal to epsilon for now to figure it out what the delta has to be. And we know delta has to be epsilon divided by 7. And then now we can erase that since we found out what the delta has to be. So this will be less than 7 times. Delta is minimum of 1 and epsilon over 7. And it's more likely gonna be epsilon divided by 7. And 7's get canceled, which is less than epsilon. Therefore, limit x approaches -2 of x squared minus 2x minus 3 has to be equal to 5. Guys, which one's gonna be on the test? You figure that out. And I gave you extra handout homework to do on 1.2. So please do those handout questions for your own benefit because this will be on the test. Okay? I will see you in section 1.3.